Good morning, everyone, and welcome to our poster presentation. I am Mohammed Hassan, and let me first introduce my team members, Nuwechian, Pongwezian, Chanhongyi, and Muzamil Adib. We will be introducing our drone, followed by the marketability and sustainability of our product. Our drone is designed for high voltage transmission line inspection. Let me explain you all the purpose and the need for drones in such applications. Do you all know that in Malaysia, 66% of the land is covered with forest? And what will happen if the trees grow taller and touches these transmission lines? Of course, they wouldn't be producing you with fruits anymore. Instead, they will cause severe flashovers. This could result in forest fires or disruption of electricity. Therefore, there is an urge to perform regular inspection of transmission lines. Of course, there exist many conventional methods, but let me inform you all today that these methods are inefficient. It is because technicians are sent for inspection. They either walk or use helicopters and visually inspect. They might use binoculars or special cameras, but definitely these methods are time consuming and expensive. According to a study conducted by the Korea University of Technology and Education, it cost around $2 million annually for the inspection. Besides, it can also be dangerous. Trust me, if I were a technician, I wouldn't prefer such jobs. Therefore, to overcome the problem associated with the conventional methods, our group has designed and built a drone with multiple features.
Hello Mr. Suresh and other lecturers. The main aim of our project is to inspect and monitor the vegetation encroachment for high voltage power grid to ensure the safe transmission of electricity by using the drone, as the conventional inspection techniques were time consuming, costly, harder to identify the vegetation encroachment and hazardous for the workers. Our objectives include the development of the line following algorithm and vegetation overgrowth detection for drone to inspect along the power line by using the image processing, implement the RF technology for data transmission and monitoring through IoT dashboard, determine the location of drone using GPS tracking to get the exact location of the vegetation overgrowth, and also to integrate the wireless charging technique for drone for the autonomous operation of the inspection process.
To overcome the challenge of vegetation encroachment inspection in high voltage power line area, the following methodology is proposed with the application of a drone and PCB. As typical drone comes with a built-in camera, we had integrated it with image processing techniques to carry out power line detection and tracking, vegetation encroachment detection, and autonomous navigation during inspection process. Next, RF technology is utilized to transmit data such as detection location provided by GPS module. RF technology is implemented due to the power grid commonly located at rural area with limited connection accessibility. At the main station, the data will be received for analysis and upload to IoT dashboard for remote monitoring of the drone operation. With IoT implementation, engineers can remotely check on the status of the drone and its operation at anywhere and anytime. Moreover, wireless charging is also implemented to recharge the drone with lesser human intervention. The drone will locate the nearest charging station to dock and recharge when the battery level is low. After that, it will continue its operation from the last known location. That's all from me. Thank you.
Good morning, everyone. With the effort of individual work, the components as proposed are developed and integrated as a complete system. The DJI Tello is programmed to follow the power line autonomously and detect the overgrown vegetation height while flying sideways using the built-in camera and image processing. A PCB is mounted on the drone with an Arduino Uno to read the GPS data of an ATGM56H module and send it through a LoRa SX1278 transmitter. The LoRa receiver on the right receives the data and sent to the computer to generate a drone tracking map. The drone can also be charged wirelessly through a XKT510 module. The drone status and the map are displayed in Node-RED-based IoT monitoring dashboard. During the implementation, tests are conducted to investigate and troubleshoot any problem found. The drone view shows the captured line contour to follow and the vegetation detected below the power line. To determine for overgrown trees, the mm to pixel conversion ratio is found to be accurate at 0.68 to judge the distance between the top of the tree and the bottom of the line through the camera pixel. For the power line following, the segmentation and line detection area is tested, and a segmentation height of 240 pixels between the red lines, a detection interest area of minimum 2700 unit pixel, and a distance of 35 cm from the line contributes to the best tracking and navigation performance. Moreover, the GPS tracking is tested with a moving car and the coordinates are plotted accurately on the map, showing the route taken in real life. For the RF LoRa transmission, the distance between the transmitter and receiver is tested against the signal strength. The chart shows the decrease of RSSI as the distance increases, which in par with the theoretical results. Lastly, the wireless power transfer is investigated at various distances between the receiver and transmitter coil. The distance of 1 to 2 mm is found to provide the highest charging current and thus the lowest charging time.
According to the report by Frost and Sullivan, the drones market in the power and utility sector would be growing at a rate of 23.6% annually. It is anticipated to make 515 million until the end of 2030. However, this project also contributes to the drone market with its unique features to identify the vegetation encroachment across the power line. It offers an automated power line inspection with IoT-based monitoring the exact location of the vegetation and the self-recharging of the drone without the human intervention. This project can be easily understandable by an average human. It is meant to facilitate the individuals from the power engineering field as the potential buyers, while it would be deployed by the major power utilities for their power line services. As in Malaysia, TNB, SEB, SESB are the major utilities providers in the 3 states.
For this sustainability section, we not only want to fulfill our objectives, but we also want to be in line with UN Sustainability Development Goals. We fulfilled the 3rd, 8th, and 9th in the SDG. So to justify on that, 3rd is on good health and well-being, referring to the social aspects of sustainability. As you know, inspecting power line is a dangerous task to perform. Therefore, by using drones, it eliminates this danger. It is on economic growth, where originally power line inspection is costly with the service and fuel. Therefore, by doing this project, it can reduce the cost of power line inspection. Last but not least, number 9, where we promote this innovative idea to the industries. Since it does not require the old method of inspecting power line through many kilometers, we have provided an environmental friendly method to inspect power lines. So to conclude this group design project, individual systems achieve good results after conducting several tests to ensure that it has the best performance in the overall system. In other words, all components are integrated successfully and thus all objectives are achieved.
For demonstration, the video shown here showcases the auto navigation and tracking of the drone along the power line. When there is a detection for encroachment, the systems will save the image for future reference or further analysis. In addition, if the drone battery level drops below 15%, it will locate the nearest charging stations to recharge its battery. To reduce the need of human intervention, the drone is implemented with wireless charging. The video shown here demonstrates the wireless charging process. Blue blinking light from the drone indicates the drone is charging its battery. At the main station, the transmitted data from the drone will be received by the RF receiver. The data is published to the IoT platform and also utilized for GPS mapping process. As shown in the not red dashboard, GPS mapping and live video stream from the drone is provided for monitoring process.